Mm, Assalamualaikum. My name is Nur Shazwani and I will present CAPM mini project. And for the theoretical part, first is operation process chart. Here is the operation process chart. The process start with machine 1 with time 2 minute, and then machine 2 time 1.5 minute, and then machine 3 with special hot process and with time 2 minute, and then the next process is cool down 10 minute, inspection 1 minute, assembly 1 2.5 minute, assembly 2 3 minute, cool down 10 minute, and then packaging 1.5 minute. Next. Okay. And here is machine parameter and circle time, production time, and production rate. For the machine 1, circle time is 3.6 minute. Uh, and then production time is 4.1 minute. For the production rates is 14.6341 pieces per hour. For machine 2, circle time is 3.1 minute, production time is 3.6 minute, and production rate is 16.6667 pieces per hour. For machine 3, circle time is 3.6 minute, production time 4.1 minute, and then production rate is 14.6341 pieces per hour. And for assembly 1, circle time is 3.5 minute, production time is 4 minute, and production rate is 50 pieces per hour. Next is check 1. Check 1 for the circle time is 2 minute, production time is 2.5 minute, and production rate is 24 pieces per hour. For assembly 2, circle time is 4 minute, production time is 4.5 minute, and production rate is 30.333 pieces per hour. Lastly, pack 1. Circle time for pack 1 is 2.5 minute, production time 3 minute, and production rate 20 pieces per hour. For the daily good and not good product, machine 1 has daily good and 117.0728 parts. Machine 2 have daily good 133.3336 part, and machine 3 has daily good 117.0728 parts. For assembly 1, daily good is 108 parts and not good is 20 parts. For check 1, daily good is 182.4 part and not good is 9.6 part. For assembly 2, daily good is 98.1331 part and not good is 8.5333 part. Lastly, pack 1, daily good is 152 part and not good is 8 part. For the monthly output, for each product, machine 1 monthly output is 2,341.456 part. Machine 2 is 2,666.672 part. Machine 3 have 2,341.456 part. Assembly 1 2,160 part. Check 1 is 3,648 part. Assembly 2 1,962.6618 part, and lastly pack 1 which is 3,040 part. Here is simulation model run for the mini project. Okay, next. And tekan next. Okay. For the simulation model run, the bottleneck is spec 1 with the lowest production rate, which is 10.3060 pieces per hour. For theoretical part, the bottleneck is assembly 2.1 with the lowest production rate, which is 13.333 pieces per hour. Problem analysis, existing model, the number of finishing part is 1,567 pieces for 160 hours of simulation. Table 6 will display the utilization and busy time for each machine. This is table for utilization and busy time for the production. And machine 1 has utilization 75% with busy time 120 hours. Machine 2 have 64.583% with 103 and 3.333 hours. Machine 3 have utilization 75% with 120 hours. Assembly 1 have 72.917% with 116.667 hours. Check 1 has 41.229 utilization and 65.967 hours. Assembly 2 has 74.542% with 190.267 hours. Lastly, pack 1 utilization is 42.943% with 68.708 hours. The machine 1 and machine 2 have the same percentage of the utilization and busy time, which is the highest number, while check 1 machine has the lowest utilization and busy time. And next, I will pass to Afsan for the next presentation.
Assalamualaikum. My name is Afzal Binti Effendi. I will continue to present for suggested improvement. First, shortening the inter arrival time (IAT) between individual sources is proposed as a means of unchanging the model. As a result of our simulation, we have experimented with extending the IAT from 8 to 9 hours in the hopes of better monitoring the ultimate result. The output, however, has been drastically scaled back from the baseline model. The accumulation of curves suggests that an increase in the IAT is not desirable, as this would slow down production. As a result, if we can decrease the IAT, we can also decrease the queues at each machine, hence increasing the overall output of the machine. This is new part manufacturing plan. Next, comparison between the previous and new. Existing manufacturing production line issues have been discussed previously. The pack machine is the source of the lowest output, as we have discovered. As a result of assembly 2 machine delay product processing, pack machine output rate decreased. Therefore, we introduce new S machine as an additional assembly machine with the same cycle time as assembly to machine. Considering new S machine is brand new, it has been had any malfunction. As a result, there is a general decline in the frequency of breakdown requiring maintenance. Along with that, we place a single buffer adjacent to the new S machine. Up to 200 units of inventory can be stored in this buffer. The plant output increased from 1,567 to 1,897 items as a result. Because of this, the entire production line ran more efficiently. Last, the conclusion. Finally, line production rate are essential for keeping the manufacturing line moving at an updated daily. But there are several things that impact them, and it's unclear which of those things is the limiting factor. Finding the machines that are slowing down production is necessary for developing an improvement strategy, such as introducing another unit with a slower output. Additionally, it is important to be cognizant of the fact that practical application of simulation may dev- deviate from their theoretical calculation. Therefore, further research is required to address this issue. It is important to think about a variety of different factors which when an emergency arises. The inter-arrival time, for instance, is an important element to manage. A machine delay might disrupt the entire production line if the IAT is too low compared to the output rate. Production rate across all processes must therefore be tightly managed. The use of SCADA and IoT for remote monitoring and management for making yield prediction are two of the changing approaches that have the potential to have a major impact on production efficiency. Overall, in the event of major failure or malfunction, the internal database system will save data record. And thank you.